Let's go on to page 2 of our Java Basics review, questions 7 through 13. So the first thing I want to do is I want to cast a number 7 to a decimal. So let's go to cast a number 7 to a decimal. A couple ways to do this. Some straight up ways, some less straight up ways. Let's start out with the most straightforward way. So double num, I've declared a variable called num and I made it a double, equals, and now I'm going to do some casting. To do that, I indicate the type of data I want to cast it to, and I give it a number. So I've initialized double num as a double with 7. So now it really is 7.0. Let's do this a couple other ways. So let's say I had an integer. So int num1 equals 7. Perfectly fine. Now I can cast that integer to a new number. So let's say I have a double. So double num2 equals, and I do the same thing I did above. I double num1. So I cast num1 to a double, num1. I can also do it a little chintzy way. So I can say double, this is kind of the secret backwards way to do this, num2 equals 1.0 times num1. It will automatically convert that because I started with a double. It'll auto make the int that's attached to it into a double. Number 8, cast the number 5.4 to an integer. So I can do the same thing I did before. I can cast a number to an integer. Now there's a couple ways to do it. First, I can say int num equals, and here I go with my casting, int, and I can just do my 5.4 there. Because I cast it as 5.4 as an int, it'll automatically drop everything after the decimal point. Now let's do it the other way. Let's say I have a double. I have a double num1 equals 5.4. Great, that's awesome. Now, I want to cast it. So I say int num2 equals, and here's that casting part, int num1. Now it'll convert it. Now, it doesn't round well. In this case, it would be fine. But what if this was 5.6? Now, rounding rules would say that that would round up to 6. But using casting rules to an int, it just drops a decimal point. So there is another line I can add. Commonly, this happens a lot. I can say num1 plus equals 0.5. And what this will force this to do, it'll either force it, if it's above, if it's 5.5 or greater, it'll automatically force it to 6 point something. If it's not, it'll just leave it as 5 point something. So when I come down here to this, I'll get a perfect rounding. Just a little trick to know. Number 9. Cast the number 90 to a string. Again, there are a couple ways to do this. The completely proper way and the less proper ways. Actually, there's 3 different ways to do it. We'll go ahead and kick all 3 and see what we can get in this. The first way I can do this is with a string method. So string, not sting, string word equals, and I can use some string methods. So string and then dot value of and then put my number in. That's kind of archaic and it's not really what I want to do, but it's legal. I could also do string word, and here I'm going to make 1 equals, I can take it to the integer class, integer, since that was an integer, dot toString. Every class has a dot toString method. 90. And it'll automatically convert it to a string. I can also do the low-handed method, and this is again one of those little things that'll help you. I can say string word 2 equals, and I'm going to use that same thing I did before. I'm going to make it start with what it expects. In this case, an empty string. And then I'm going to concatenate onto it the number 90. Because the first thing it got was a string, everything after that's a string. So I end up with 90. All three of these methods work. Pick your method. Number 10. What is the result of the following expression? So I've got 5 times 4 inside parentheses. I've got 8 divided by 2 inside of parentheses, and both of those are added together as inside of parentheses. Then I've got a minus 6 minus 2. So I'm going to work inside parentheses out. This is how I'm going to do it. So the first one is 5 times 4. That's this here. That's inside these parentheses. Well, 5 times 4 is 20. Then I'm going to add my plus sign. And then 8 divided by 2, that's inside parentheses, so I got to do it first. That's 4. And then that's in parentheses. Minus, and I have my 3. I'm still in parentheses. 3 times 6 minus 2, which is 4. Go and clean these up some more. 20 plus 4 is 24. Then I do the minus, and 3 times 4 is 12. That gives me 12. Now, I incorrectly stated in class that when you do division, it automatically makes it a double. It does not. That's a different language. Inside of division, this is just straight integer division. It results in a straight integer answer. So my answer is 12. Number 11, what is the result of the following expression? Going to do the same thing I did before. I'm going to work inside my parentheses out. So first in. So I've got 15 modulo 4, which means, remember, modulo means the remainder of. So 15 divided by 4 is 3. That's 12, with the remainder of 3. So that's 3. Then I bring down my thing, or my multiplication. And the next one I've got is 6 plus 2 inside parentheses. Well, 6 plus 2 is 8. I go ahead and take care of that. Then between those, I've got a division, and then I've got another one. 3 plus 7 in parentheses is 10 minus 5. So over here, 3 times 8, well, that's 24. Then I've got a division, and remember, this is integer division, so the result is going to be just a straight integer divided by 5. Well, 24 divided by 5 is 4. Number 12, what is the result of the following expression? Here we get in a little bit of methods. We've got the math class, which is a static class, meaning I don't have to make an object. I can just use it straight. And this one's the power of, and 2 is the base, and 3 is the exponent. So keep track of my parentheses. I've got a couple in here that are going to get a little tricky, because there's 2 to leave this one out. So math pow, 2 to the third. That means 2 times 2 times 2, which is our 8, plus 10 divided by 2, which is 5. Now we close parentheses. Times 5 minus 3 is 2. Then we got to close our second set of parentheses now. Minus 7. So we go down here, we'll still work our way through. So 8 plus 5 is 13. Times 2, close our parentheses, minus 7. Whoops, minus 7. Keyboard's not my friend. We got 26, which is 13 times 2, minus 7. That gives us a total of 19. So number 12 is 19. Number 13, what identifies something as a method? Now, I'm not talking about what parts make up a method. That would be the signature, and I'm not really concerned about that right now. I think I'll cover it just because I can. But what I'm looking for is visually, how can you recognize a method? So a couple things. Methods start with lowercase letters. So they start with, that's just the way they're built. And they're followed by parenthesis, this, and that's with or without parameters. So they can have parameters, they don't have to have parameters. If a method is directly to a class, then it'll be preceded by and it's preceded by a period. Or as people commonly say, dot. Now, a method signature, and that kind of goes a little farther on. I'll cover it here. So method signatures often tell you what it is. It's either public or private. So public means that anyone can access this. Private means it can only be accessed within that class. Then a method will have generally static. It is optional to write. It'll have a return value. So in this case, void means no return. It could say int, double, whatever you're getting back, string. And then it'll have a method name. Starting with lowercase, using the camel case, and then parameters. So int a string x. And it contains a block of code that we know is closed by curly braces. That's generally how a method looks. So this helps you recognize the method in your traffic. Hope these are helpful. Next one we'll cover the next page.